yeah, so let us proceed forward with the next chapter, that is cryptography. We just have 1.5 hours to complete cryptography, so it's going to be a bit rushed. I'm going to give you um, certain topics that you need to cover on your own. But if you have any queries, just raise your hands in the middle and I'll try to answer them. All right, and one more point is that in the documentation that Atul provided, you'll also have certain questions. You can attempt those questions, understand, get the feel of a CCNP level MCQ based questions. So that also can be done. All right. Okay, what is cryptography? Let's start from there. Anybody has any idea or would want to share their information or knowledge about cryptography?
Basically, ma'am, I was working in cryptography in my environment,
Okay,
but I don't know. But I don't know what is cryptography. I seriously don't know.
that's fine.
What
So
was
what
the
were you working on?
basically, ma'am, we configure router and switches. So we configure cryptography configuration on a router.
So what is the cryptography configuration that you configured in the past?
There is some IPs. There is a server in CO in Mumbai,
Okay.
and some of IPs we configured in our branch level and DO level routers. Um, without cryptography, they never connect with this with their environment. They have reachability issues. They have configuration level issues.
Is there a possibility that you might be configuring a site-to-site tunnel between routers?
No, ma'am.
Okay. So cryptography is generally used in site-to-site tunnels. It is used in remote access VPN. So cryptography or cryptology is the study of the techniques that are used for encryption and a secure communication. So cryptographers are the people, for example, Azmat might be a cryptographer if he researched about how to build an encrypted and secure channel. So cryptographers are the people who study and analyze the cryptography or cryptographic procedures. Cryptographers are always constructing and analyzing protocols for preventing unauthorized users from reading private messages, as well as following areas, as well as there are certain areas of information security in which the cryptographic algorithms are used. And they are, again, if you recollect, we've studied this. They are data confidentiality, data integrity, the authentication of the secure channel. So all these solutions have cryptography as the focal point in order to safeguard themselves. For example, in data confidentiality, what is used is cryptographic ciphers in order to encrypt data. Similarly, in data integrity, we have hash algorithms in order to ensure that there is no change of data payloads in transit. Then you have authentication. Authentication, the example of cryptography being used in authentication is when you are authenticating routers before they form a site-to-site tunnel. They exchange a pre-share key, or if they are using certificates, they exchange certificates. So this exchange of pre-share key or certificates is done on open internet because at that point the site-to-site tunnel is not up, right? So that means it's going over the internet. So that pre-share key needs to be well, for a better word, it needs to be encrypted, or that bunch of certificates that are transferred from one router to the other needs to be encrypted. And that is done before the site-to-site tunnel or before the encryption of the data traffic of the site-to-site tunnel is even implemented. So you should have measures in place in order to protect those authentication passwords as well. So that is where a cryptographic cipher is used. So A focal point of a focal concept under cryptography is what is called as transport layer security, or TLS, that is used internet wide. Without TLS, an HTTPS connection cannot be formed. Without TLS, a remote VPN session cannot be formed. And you will understand the importance of TLS as we go on about understanding firewalls, understanding VPN and AAAs. So in this topic of cryptography, I have talked about cryptographic ciphers. Now I'll just write here so that we can have a mind map on whatever we have studied, right? So first is what is cryptography, right? And as we discussed before, cryptography is the study of the techniques used for encryption and a secure communication. It helps in making your data confidential. That is, data should not be snooped on by man in the middle. It helps to ensure data integrity. That is, data is not changed in transit. It helps in authentication. All right. There are other aspects in which a cryptography algorithm is used. We will study that in the future, and we'll study how those topics also merge into data confidentiality and data integrity. Anyways, so that is what is cryptography. Now I've talked about cryptographic cipher, that is used in an encryption algorithm, that is used in a hash algorithm. So that begs the question, what is a cipher? So a cipher is nothing but a set of rules, which can also be called as an algorithm. So cipher, so when people say cipher, cryptographic ciphers or cryptographic algorithms, they are generally referring to the same thing. So don't get confused when I say cryptographic ciphers, or don't get confused when I say a cryptographic algorithm. So anyways, so what I was saying is, a cipher or an algorithm is a set of rules, and it dictates how to perform encryption or decryption. There are hundreds of encryption algorithms that are available out there, and some of the cryptographic algorithms are proprietary. That is, they are specific to Cisco or they are specific to Juniper, and some are used everywhere. So they are specified by the ISO or international bodies, and they are free to use. So I want to cover what are the methods that a cipher can be used, or a cipher can be implemented to encrypt or decrypt data. And if you recollect, this topic was covered in our BTech examinations. There was a topic on cryptography and ciphers when I was doing BTech, at least, and I think it might still be out there. So it told about the various ciphers that are out there. If you ask ciphers, or if, yeah.
Block cipher, the type of the cipher is a block cipher.
Exactly, and that is what I was getting to. If you ask a network professional what are ciphers, the common ciphers that pop up into a network professional's mind is block cipher, or MD5, or SHA, etc. These are ciphers that are used for encryption and hashing, but there are other common ciphers also that are out there. For example, one is substitution. So substitution means, for example, reverse substitution. Like, so for example, you have A, B, C, D. So you have created a key wherein for A, you use 1, for B, you use 2, or for C, you use 9. I don't want to go in serial order. And for D, you use 6. So now ABCD becomes 1, 2, 9, 6. So you have substituted a character to another character, so that when you then write, so that when you then write a chunk of data, it becomes indecipherable to the person who does not know the key. Now, what is a key? Key, as you might have understood, is the substitution algorithm that is used. That means what does 1 stand for? 1 stands for A. What does 2 stand for? 2 stands for B. So that is the key that is used in order to cipher A, B, C, D. So if you have to write BAD in this, using this cryptographic algorithm, BAD would become 216. Now 216 for an unknown party, he'll not be able to understand until unless he has the key. So that is substitution. Very simple. I'm pretty sure that you might have studied this in your engineering as well. It's nothing. It's nothing great. It is not used, of course, in industries because it's too simple. And then is another is transposition, right? So transposition is changing the way in which it is read. So that is the meaning of transposition. This is the method that is used by rearranging the letters of a string that makes sense. For example, it is the
Hello, ma'am.
yeah.
Ma'am, it is basically rearranging the letter in encrypted manner, ma'am, to get the encrypted text.
All these cryptographic algorithms?
No, ma'am, only transposition, ma'am. In tabular form of data making and then matching with the column and row wise.
Exactly. So it is changing the direction of the string in order to make it unintelligible for the person who does not know about the key again. So I have written a block of data. This data to me makes sense because I know what is the key. The key is a transposition cipher. I have written the text vertically, but of course we humans read the text horizontally. So for a novice person, this becomes an unintelligible code. But for a person who has key, if I provide a key to the party, for example, that it is transposed vertically, if I tell it to a party, he will read it as an intelligible code. So it is the bag is on the table. The bag is on table. So this is a meaningful code to a person who knows that it is transposed vertically. So essentially that is known as a vertical transposition. This is generally so when I talk about this, it is not used. It might be used in gamings, etc., but we'll not cover that. But it's not used in security infrastructures because it is too easy to break. Okay, then coming back to the more important ciphers are block and stream ciphers. Very important. These are used in these times. So encryption algorithms can always operate on blocks of data at a time, or bits and bytes of data as they come in and as they are processed by a receiver or a sender. Block cipher is a symmetric key cipher. What does symmetric key cipher means? Symmetric key cipher means that the same key is used for encryption and decryption that operates on a group of bits called as a block. So a block cipher encryption algorithm may take up to 64-bit of block of plain text and generate a 64-bit block of cipher text. So with this type of encryption, the key to encrypt is also used to decrypt, because as I said before, it uses a symmetric key cipher. So examples of symmetric block cipher, and I'm sure you might have come across them at some point of time, is AES. Then is 3DES. DES is also a type of block cipher. And then you have other block ciphers that are used for limited network infrastructures not used out in public. And I'm not sure if you would know about them. They are called Blowfish, and the next block cipher is International Data Encryption Algorithm. The important ciphers are AES, 3DES, DES. Blowfish and International Data Encryption Algorithm is used to some extent in federal environments, but still not used. So not used in industry terms. I mean, even I also did not know them before studying about this course, going through the material of this course. So it's fine. Let's not focus on this. This, however, is used in site-to-sites. This is used in this is AES is used in EAP authentication, etc. So pretty important. So they are block ciphers. Block ciphers means they that the algorithm is run on a block of data. So in case you might think that not all data that has to be transferred can be segmented into 64-bit of blocks. Sometimes the last block can be a 10-bit block. In that case, if that happens, then we add something, or network devices add something that is known as padding. Padding means they add a chunk of zeros, complete the 64-bit block, and then run the algorithm over it. Now we've covered what are streams, we've covered what are block ciphers. Now let's cover what are stream ciphers. So a stream cipher is also a symmetric key cipher, where the plain text data is to be that has to be encrypted is done bit by bit. So it's not done on a 64-bit chunk of data. It is done by it is done continuously. So, and that cipher, the output stream that comes out is called a cipher digit stream or a cipher text stream. The cipher text stream that comes out is of course indecipherable because it has been encrypted and worked upon by the stream cipher. So because a given algorithm, depending on what algorithm is used, the cipher text stream does not have to fit in a given block size of data. There may be slightly less overhead than the block cipher because, and why is that? Because in stream cipher, there is no use of using padding. So a 10-bit chunk will result in a 10-bit cipherable data. It will not result in a 64-bit cipherable data because there is no padding that is needed. So that is the difference between stream ciphers and block ciphers. We'll understand later as to why stream ciphers are not, that when stream ciphers are used and when block ciphers are used. Okay. So we talked a lot about symmetric keys and asymmetric keys. I just would want you to go through the difference between a symmetric key and an asymmetric key. As I told before, it lies the difference lies in the fact that in symmetric key, the same key is used for encryption and the same key is used for decryption. But in terms of, when we talk about an asymmetric algorithm, the keys that are used for encryption are not the same that are used for decryption. So examples of symmetric keys are these, right? So the examples of asymmetric keys are RSA. Let me write that. Okay. Examples of asymmetric algorithms include RSA, a very important algorithm, Diffie-Hellman, and other common examples are elliptic
MD5.
curve crypto. MD5 is a hash. It is not, I don't think MD5 uses an asymmetric key because it's a hash. So MD5 is an algorithm that is run on a chunk of data. The digital signature that comes after an MD5 algorithm is then compared to the hash that is calculated on the receiver end, and both the hashes are matched. Yeah, that's hashing algorithm. We'll study that later. So Diffie-Hellman, and another important elliptical curve cipher is ECC. Other important asymmetrical cipher is ECC, that is elliptical curve ciphers. A very important cipher when it comes to modern day security systems. So an asymmetrical algorithm or asymmetric ciphers require more CPU processing than the symmetric algorithms. But as you might have understood, asymmetric algorithms are more secure because, of course, you require a different key to decrypt than to encrypt. So even if the encrypt key becomes compromised and is known by malicious party, it still needs to get the decrypt key in order to decipher the data traffic. So it's more secure, but it adds more CPU processing of the receiver also and of the sender also, because you require two separate mechanisms to encrypt and a separate mechanism to decrypt the data. So anyways, let's come to hashing, right? Okay. Okay, anybody here can tell me the difference between encryption and hashing? We covered this back when we were covering the difference between confidentiality and availability. Yeah.
Hashing provide hashing values.
Hashing provides hashing values. What does that mean?
That means, just a second. I have.
Okay. Has anyone here downloaded a Cisco software from the internet? Maybe for your professional job or just out of curiosity? Anybody who has downloaded a Cisco software from their official site? Okay. Have you ever noticed that after you've downloaded a software, there comes an option next to the download button? It says checksum verification. Okay. Okay, never mind. So hashing is a method that is used to verify data integrity. This is in comparison to encryption that is used to safeguard data confidentiality. So data integrity, what is data integrity again? Anybody here?
Ma'am, data maintain and not lost from both
Not
sides.
should be changed. Not should be changed.
Yeah.
Not should be changed and not lost, ma'am.
Yeah, correct. So it should not be altered in transit. So how do you safeguard it? How do you measure? How do you ensure that it does not change or it does not alter? We have hashing algorithms that ensure that data integrity is maintained. So when I asked about examples of you downloading a image or a software from the Cisco official website, once you download it, you always have an option to verify its checksum or verify using Md5 algorithm. So that verification is used to ensure that that image or that software package is not corrupt, because software package goes on routers, they go on firewalls, a very important piece of package that you download from Cisco. There is always a possibility that that package, while it is getting downloaded or while it is getting copy pasted from one network administrator's pen drive to the other network administrator's pen drive, that it can get corrupted. And once you load a corrupted image on a router, the router is going to crash most probably, or the firewall is going to crash. So you don't want that as a network administrator. So before you start a boot process to upgrade routers or to upgrade firewalls, you always verify the checksum of the image that you are loading up on your router. And that verify checksum is to ensure that the image that you have in hand is the same image that Cisco has made public. So that is what is known by checksum verification, or verifying the image using MD5. Okay, and another example of using a hash to verify integrity is the sender running a hash algorithm on a packet and attaching that hash to it. An example of that you'll study when you study Nat in IQ1. Anybody here has dealt with IQ1? It's an algorithm. IQ1. It is an algorithm, or it is a protocol that is used in building up site-to-site tunnels. Okay, if you have not, then you have quite a few interesting topics that that we will cover when we would be doing VPN. So essentially, I'll just give you a brief of how hashing is used in IQ1. So there is a mechanism in IQ1 called as Nat or Nat Reversal. Nat Reversal in IQ1 is used to understand if the particular router is behind a NAT device or not. Because if it is behind a NAT device, you need to change the port number on which the IPsec tunnel is set up. You'll ask, why is that done? I will tell you that when we would be doing site-to-site and VPN, and just note that down as to why NAT is used, and make sure, if I forget, make sure to ask this question to me while I would be doing site-to-site tunnels, so that we understand, because it is the most important interview question. If you get an interviewer that has worked on VPN, any interviewer, you take my word for it. If you sit in an interview, sit in a Cisco's interview, or sit in any organization's interview, and they start asking you about VPN and site-to-site tunnels, they will always ask you about NAT reversal. So it is it is the most favorite topic of any interviewer. So anyways, NAT reversal is a mechanism used to understand if the router is behind a NAT device or not. And the reason how it is done is that a hash is formed using the source destination, and the using the source destination and the port number. And then you match the same hash, the similar hash that is calculated on the receiver. And then if it is different, that means it is sitting behind the NAT device, because the function of a NAT device is to change the IP address, isn't it? Everybody here knows what is a NAT device? NAT. Okay, what is a NAT device? Can you please tell the folks that have not unmuted themselves and not confirmed it?
Ma'am, no, ma'am, I don't know, ma'am.
NAT device basically doing translation of IPs. It should be private to public.
That's right. So anybody here who does not know what is a NAT device, that is NAT, NAT device, focus on your, along with the homework that I give you, focus on your networking concepts as well, because there would be a couple of keywords that I would just speak and you wouldn't understand, and I would take for granted that you would know. So either ask me that on chat here on the Zoom chat, or you can ask me on the chat if you have this question over the weekdays as well. or either or brush up your basic concepts, because I took for granted that you know what is a NAT device. And if you don't understand what is NAT device, you probably would not understand this example. So it's very important that either you make me realize that you do not know, or brush up your basic concepts, or just ask me offline on chat. Okay. So as you clearly correctly told, that NAT device is used for translating IP addresses. It is used for translating source IP addresses and also source port numbers in certain cases. So it is done for a myriad of reasons. I'm not going to cover all, but just read through a NAT device. All right. If you have any questions on the working of a NAT device, etc., you can always get back to me. And NATing is very important when you study firewalls as well. Because you have a very different way in which the firewall handles NAT, and in way routers handle NAT. So you need to be you need to understand what is NAT. Anyways, so NATing means that you change the source IP address, or you change the source port number in order to transfer packet out into the internet. So when you build up a site-to-site tunnels, it is crucial to understand if the router that you are peering with is sitting behind the NAT device or not. And for that, IQ1 uses a mechanism known as NAT translation that uses a hash algorithm to create a hash of source IP address, destination IP address, and source port number and destination port number. And the hash is made on the sender as well as on the receiver independently. And then both the hashes are matched on the receiver once the receiver receives the hash from the sender. If the hash matches, then we conclude that the peer is not sitting behind the NAT device. If the hash does not match, then the peer sits behind the NAT device. And that is how you get to know, because it impacts what happens next in an IP1 tunnel. So anyway, so that is another example of where a hash algorithm is used. Okay, let's list out the popular hashes that are out there. When I say popular hashes, I mean popular hash algorithms. Md5, okay, SHA-1, and SHA-2. Now, SHA-1 and SHA-2 use the same basic algorithm. The only difference is that SHA-1 uses a 160-bit digest, and SHA-2 uses a digest which is ranging between 224 to 512 bits. And the more big the digest is, the safer the algorithm. The safer the algorithm is. So that means your SHA-2 is more secure than SHA-1. And the reason why that is because of quantum computing, because of computers that are out there. You can run codes to hit the random number that is used in the algorithm. And once you find out the random number that is used in the algorithm, you have cracked the code. So bigger the random number is, bigger the time taken to crack the code. And that is the reason why you have expiry timers. That means the random number is only valid for, say, 1 day or say a couple of hours. So that because if it is because if that random number is valid for a perpetual number of time, there would be a time where the computer will crack that random number, right? So That's the reason why a higher bit hash algorithm, or for that matter, encryption algorithm, is always safer than the algorithms that use a less bit digest, or less bit size of the digest. So SHA-2 is safer than SHA-1. So bigger is always better. So you have SHA-3 also and SHA-5 also. So SHA-2 is generally 256, SHA-3 is 384, SHA-5 is 512. Okay, now there is something which is known as Hmac. So Hmac stands for Hashed Message Authentication Code, and it uses a mechanism of hashing, but it works at a higher level. And let me tell you why. So instead of the Hmac using a hash that anyone can calculate, as I informed, if they get to know the random number, Hmac includes in its calculation a secret key as well. So only the other party who also knows the secret key as well as gets the random number can calculate the resulting hash that correctly can correctly decode the hashing algorithm. So when this mechanism is used, an attacker who is eavesdropping or intercepting packets cannot inject or remove data from those packets without being noticed, because he cannot recalculate the correct hash for the modified packet because he does not have the key or keys that are used for the calculation. So Md5 is a hash function, so as we listed here. So Md5 is a hash function that is insecure and should be avoided, and is not used generally in site-to-site now. It was probably used 20 years or 15 years from now, but generally SHA algorithms are used. Under SHA as well, SHA-1 is a legacy algorithm as noted by Cisco. SHA-2, that is SHA-256, working on 256 digest, provides adequate protection for sensitive information. And that will only be valid if no technological advancements in quantum computing is made in order to quickly decipher the digest. So for now, SHA-256 is considered adequately protected. So on the other hand, SHA that is working on 384 bits is required to protect classified information for higher importance, because SHA-384 is bigger and better. It uses digest which is of 384 bits. So Hmac, as I talked about, is a construction that uses a secret key and a hash function. So it is more reinforcement of a hash algorithm that provides a message authentication code for a message. So Hmac is used for integrity verification, of course. So you have something which is, so Md5 in its entirety is not is insecure now. It has been deemed insecure, but Hmac Md5, which uses Md5 as its hash algorithm, can be used in certain circumstances which does not require security up to that level, but is still a legacy algorithm. So essentially, that is what is Hmac. So it adds a reinforcement on hashing algorithm. So let me just write so that you don't get confused. Okay,